Hello all, welcome to this video. Here we'll take a look at a React application. We'll go over some features of React like the virtual DOM, declarative style of writing the UI, React components, which are stateless functions and stateful components, state of these components, and component lifecycle. So before we start, let's just take a look at this application, what it does. It's a single page application. The home page shows the information about trading books. So here on the left hand side, I list out all my trading books. There is a search. So if I search for a particular term, it will return all the trading books which have that search term. Then if I click on a particular trading book, I'll see all the portfolios in that trading book and the transactions. These two grids need some formatting. Next page is transactions. So here I'm listing out all the transactions that are in the database. I can filter them. I can filter only the open ones, um, closed ones, cancel transactions, and also the date range. Finally, a report on the backend jobs which are running. So these are the jobs which ran today, and they are shown in three different grids. One shows the in progress jobs, completed ones, and the failed ones. So let's take a look at how this is built and shed more light on these points. Virtual DOM is one of the reasons why React is so popular. It has a diffing algorithm to only regenerate in the browser's DOM what actually needs to be regenerated and keeps everything else as is. So this is possible because of the virtual DOM. React keeps versions of virtual DOM in the memory and sends to browser only what has changed in the DOM. So this way it doesn't have to render the whole page for a small change. It will update only that small change in the page. Next is declarative style of writing UI. This is a great example from Sameer Buna. I couldn't find a better example, so I'm using it here. So suppose you need to show a notification in case you get messages. If it is more than 0, then show the count, and if it is more than 9, show the count as 9 plus, but also change the background image to red. If you've come from jQuery JavaScript background, you can imagine how many if clauses you'll have to use to take care of the data transitions. If the count increases from 0 to 1, show the count. Again, if it goes from 1 to 0, remove the count. If count increases from 9 to 10, show red image. If it decreases from 10 to 9, again show blue image. That would have been a lot of lines of code. But in case of React, you can write it this way. So the text, if it is greater than 9, then show this, else just show the count. And the notification will be, if it is greater than 9, show the red image, else it will be blue image. And if the count is greater than 0, only then show the count. So you can see that it is much clearer to know what's going on, and it is easy to represent the behavior. Moving on, let's take a look at React components. This homepage is a component called Trading Books List, which comprises of two other components, which is a trading book and two data grids. So each of these list items is a component, which is a trading book, and we pass on the book value to that component to display the details. So in this case, it's a link. So if I want to make a change, these list items to look like a card, I can do that, and I know where to make the change because that change is in this trading book. So I can change this li into a card and change these items the way I want. Then these two grids are a reusable component called the data grid. So data grid is nothing but a stateless function. So this is what a stateless function looks like. It doesn't have a state on its own. It is not a component. It is just a function which takes some props and returns HTML. So this is reusable. I can send any data and its columns and it will display the grid for me. Abstraction, uniform behavior, separation of concerns, and data hierarchy. So this data grid component shows abstraction. I mean, we don't care about what it uses to show the data in a grid format. All we do is send it the columns and the data, and it's the component's responsibility to show the grid. We need not worry if it is using a React grid or a AG grid. That's all abstracted from the parent component. So we already saw a stateless function, this data grid. Now let's look at a stateful component. We already saw this trading book. This is a stateful component. It extends from react.component and it has its own state. So in this case, the state is coming from Redux, but that is not required. You can use Redux, but the application will do just fine without it too. So this is coming from Redux, and this component is passing on this data to the child component to display. So this is what a stateful component looks like. You can see one more example of a stateful component, which is this jobs list. Again, it has a state. We are not getting the data from Redux, so this is a good example. So it defines state. In this case, the row data is empty when it initializes. On component did mount, we are fetching the data into row data, and then we are passing the state data to the child components. So essentially, React components are like functions. They take some input, which is either props for the stateless functions or state for a stateful component, and give an output, which is HTML. And if the state changes, it will re-render. And one more important thing, in the render method where it returns an HTML, input anything which returns something. So you can do a math.random. You can use a ternary operator for rendering one or the other component. So inside this curly braces, you can write anything which returns something. So let's move on to the next topic, which is state. So state is the internal input for a component, and it is part of the input that controls what renders on the screen. It cannot be passed from one component to another, and the owning component only has control over it. If the child components need to make changes to the state of the parent component, you can do that by passing a function from child to parent, and that function can change the state. Finally, you can access any property from the state object by doing this dot state dot that property, and you can set a state by doing this dot set state. Let's take a look at an example. So this whole is one component which is called transaction reports, and it has two child components. One is the filter. This is a component, and this is the other component, which is a grid. So this is the transaction report component, and like I said, it has two child components. One is the filter and the data grid. So in this case, we are getting the state from a Redux store. Instead of getting it from Redux, I can directly define it here. This dot state equal to an object which will be these transactions and an empty array. So this is how I can initialize a state. But in this case, we are getting it from Redux. So in component did mount, we fetch the data into our store. Once the data is loaded, we can pass that data to the child component, which is the data grid. So again, this is a reusable component. Now the second part, where the child component was supposed to update the state of the parent component by sending a function. So we are not doing that exactly here, but we are sending a function to the parent component here. Let's take a look at that. So every time we click on a filter, it calls these functions, and those functions in turn call the parent function, which is sent through props, which is set filter. So suppose you send a value from here, you can set the parent state like this dot set state, say some property and the new value. So you can do it like this. So moving on to our next topic, component life cycles. Component has these 7 life cycle methods. Before the component mounts, this is called, and you can check all these by putting a debugger. Before the DOM loads, this is called. After the DOM loads, this is called. So component did mount is the place where you can initialize your data. Then so these 4 states are when there is a change in the props or the state. So before it receives the props or state change, this will be called. This is a special one. Here you can check for something, and you can not allow the change to happen. If you return false here, the change won't proceed. Then component will update and component did update. Here you can get the values of next props. You can compare it with some value, and you can add some logic in these 2 life cycles. And finally, component will unmount. So if you remove a component from UI, this lifecycle method is called. Suppose in did mount you subscribe to a state or an event or something, you can unsubscribe in will unmount. So those were the topics I was going to cover in this video. In the next videos, we'll look at how to use Redux with React, and next would be router, how to use React router. Thanks all for watching this video.